Hi, I'm Seth Stein from Northwestern University, and I'd like to talk to you about dealing with the news media. This is something that, as earth scientists, we often encounter. And so I'd like to give you some ideas based on my personal experience, it's a very informal introduction, of some ideas that you might find helpful in dealing with this as you go through your careers. Now, so what I'm going to do is just share you some things, some ideas that I've learned sort of the hard way over about 35 years of dealing with the media. Now, I wish I'd known these when I was in grad school or when I was getting started. And as I've learned more about this, can share some ideas that hopefully will make dealing with the media less scary, easier for you, and actually more effective. Now, because the geoscientists interest the public, we deal with a lot of things that generate public interest. So we have a lot of media interest. And that often happens fairly early and sometimes unexpectedly in our careers. A number of people will encounter this when you're in graduate school or as an early career scientist. Now, that means we have a lot of opportunities to explain what we do. So if you're interested in trying to explain what you're doing to the public, dealing with the media can be fun, can be interesting, and it can help shape the resulting story in terms of giving the public a better understanding of what we do. So the biggest thing I'd like to talk to you about why and when you should talk to the media, and then how to go about doing it. There's lots and lots of good advice out there, many things, including on the AGU Sharing Science website. So first magic rule, the most important thing in dealing with the media is you don't have to talk to them. So you should talk to the media only when you want to. The fact that they want a story isn't your problem, but it is an opportunity to tell people about things. So working with the media involves mutual interest. It works when you have a story you want to tell and they're interested in hearing about it. And I'll give you some examples of all these things as we go through it. This is right after the huge Sumatra earthquake. My colleague Emil Kal and I learned some very interesting things about how big the rupture was and the magnitude of it was that we got a lot of worldwide coverage for, and it was a useful and constructive experience to explain what we were doing. Now, by the way, one funny thing looking at this is you'll see that for the purposes of the newspaper photography, they wanted us to show what we were looking at. So you notice if you actually look at what we're looking at, we're looking at a blank piece of paper because, of course, we're showing the image so that you can see it in the news photograph. So, there are compromises one makes, but usually in this case, at least it helps with clarity. So first thing is, why are you going to do this? And the rule is you should be clear why you want to talk to them. There are many reasons to talk to the media, and here's some. One of them is to explain your science to the public. So here's one. Relatively early in my career, we dealt with an infamous sort of nonsense prediction of an earthquake in the New Madrid seismic zone that generated actually a fair amount of public concern, and they closed schools, and there were, all kinds of things went on. I was invited to participate in covering this event for CNN, and the whole thing was completely stupid. And so we had the opportunity to help, like many other seismologists, explain that this was all absolute nonsense, that nothing was going to happen. And maybe we did some good. I don't know. I hope so. What's another good reason to talk to the news media? If you've come up with a really interesting result that you'd like to communicate to the public, purely in terms of helping them understand the science better. So one year, colleagues and I had been working US and Canadian researchers had been able to observe using GPS data, the glacial rebound or glacial-isostatic glacial-isostatic adjustment, to be precise. In other words, Canada rebounding, US subsiding was a really impressive example of what we could do with what was then very new GPS technology. And So, this drew a lot of interest. We had the front page of a lot of newspapers, and we had no particular agenda for this beyond so that this was a really neat result showing what we could do with genetic methods, and it seemed worth trying to share them. Another case we might want to do this is when we want to have an influence on a policy discussion. We want to either promote or oppose a policy that we favor or oppose. And so here's an op-ed piece that I and Joe Tomasello, a structural engineer from the Memphis area, wrote from the New York Times. And we basically were trying to explain that it would not make economic sense to take an area like Memphis, where the seismic hazard is a lot lower than California, and build to the same standard as in California, that one should adopt a standard that was in somewhat keeping with the lower seismic hazard there. And the idea was to help the people in Memphis and the state of Tennessee and surroundings come up with a policy that made more economic sense. Also, it's fun, and talking to the media simply because it's fun is a perfectly legitimate thing to do. Here was a talk that I gave for the BBC that basically on a talk that I gave at a GSA meeting, where we basically showed how we could use scientific errors to engage students, and use the mistakes in the media to help for teaching purposes. And we had a lot of fun explaining this. For example, there's a widely cited educational video claiming that the earthquakes of 1811, 1812 in the central U.S. seismic zone, in the Madrid zone, were the largest earthquakes that ever occurred on Earth, which of course is utter nonsense. But it's fun to point out things like this. We looked at mistakes in earthquake movies, mistakes in the movie The Core, many things like that. And this was a fun story that we did purely for the fun of it. Now, if you're going to talk to the media, you want to think about the kind of media that you'll be dealing with. And there's some overlap, but there's a couple broad classes. One of them are national and international electronic media like CNN, NPR, PBS, and so on, or major networks. There are national and international print media, New York Times, the Chicago Tribune, et cetera. Then there are media that are somewhat more scientifically savvy. Nature and Science have very nice science reporting, as do things like the National Geographic and some other science magazines. We also have regional newspapers, and we'll have regional and local electronic media, TV, radio, et cetera. And those can be pretty good. In some sort of average way, the national media will be a little better than local media, but that's not a given by a long shot. It very much depends on the reporter you get and how serious they are about it. Then there's another broad class of things involving YouTube, like this, Twitter, any one of a number of social media. Now, those have the advantage that they're easy to produce on your own. You don't have to work through an interface through a network. On the other hand, they're harder to get attention. Now, what you're going to expect depends on how seriously they're going to take it and how much time and effort they'll put into it. So I've had, for example, good luck with the History Channel, among other things. So, you want to think about what their agenda is, but it's important I would say, be open to anybody who's interested, because, it could be a very useful opportunity. The really important thing then is to think about what kind of story they'll be doing, because you want to work with the media in terms of what they need. Now, the most common thing, at least in my experience as a seismologist, are event-driven things like an earthquake, a volcano, a flood, a hurricane. These are very time-sensitive stories. They want a story about this and they need it now. And so you need to be very responsive to their needs. A lot of us were interviewed after a court case in Italy where some seismologists were brought criminal charges because it said they'd failed to predict the earthquake. And so we tried to explain what was going on there. Feature stories where they're looking at a big picture aspect are less time sensitive, and they'll often give you more opportunity to explain your story, and they'll be working it up over a period of time. Here's one that we did for the BBC World Service about forecasting earthquakes. We had a lot of time to explain what the basic science issues involved were. Another class of things are discovery reports, and where you have some report and you'd like to tell people about it. the news media often refer to a pseudo event. That is, the presentation of a paper at a meeting or the publication of a paper is something that can be reported on because that makes it news. So for example, here's some nice coverage we had for a class project where we looked at the Illinois Emergency Management Agency had said that people in Illinois should secure their water heaters to protect them against earthquakes. And it was a little hard to see how that could make any economic sense. So our class looked into this phenomenon and then wrote a paper and concluded that actually, if you were going to spend the money securing your water heater in the Chicago area, you'd be better off putting the money into the state lottery. And it was a fun story that got a lot of interest. The last thing you get are profiles where the media might be interested in you. This is less common, but sometimes happens. And they want to do a story about you. And that gives you a lot of opportunity to try to explain how you view various issues or how you view the kind of science that you do. Having decided what that is, then your next issue is to decide on what your message is. And a really important thing to realize is that the nature of the media is that a long interview will often turn into a 20-second soundbite or a short punch quote. And so the trick is if either you choose the soundbite or they will. So you should decide what your message is and be sure to state it in a very clear, one sentence, very pithy way, kind of like the way in Silicon Valley they talk about an elevator pitch that the these researchers will give to a venture capitalist. With us, it's very useful to get that up front. So when me and Lou from the University of Missouri and I worked out that many recent earthquakes are actually aftershocks of large earthquakes that went on for hundreds of years. This was kind of a new idea that we realized that within plates, you could have very long aftershock sequences. And we made a point of getting that out at the head of every story. So it says aftershocks of large quakes that occurred hundreds of years ago. First, we said, this is a new idea. Here's why it's important. This is why we think it's happening. Really important is you don't need to answer the media question. If they're going afield from what you want to say or into a topic that you don't feel that you are capable of discussing fairly or that you don't want to discuss, then just return to your message and explain what you think you're trying to say. So don't get dragged into saying things you don't want to, because you'll feel very silly afterwards with what comes out. So the idea in general is you want to be responsive to what the media needs. They're going to need a timely story. It's going to be a good story. It's going to be a clear story. But don't degrade your message. You're going to learn to run a tricky balance between simplifying the message to make it clear without saying something that's wrong. Now, there's no right way to do this. There's a lot of advice out there. Here's a very nice checklist from the AGU Sharing Science website. So be yourself, be honest, be clear, and be helpful. A really good piece of advice is when you see other scientists, especially if you know them, but other scientists in the media, look at how they did and assess how well they did, and you can get some useful insights. And the next thing is another really important thing to accept is that no media contact works perfectly. You'll think you'll have said certain things. They may not have clearly understood what you've said, or it may not have worked well in terms of their story. So don't worry about getting it absolutely right. This is not like a published paper. You're going to get it as right as possible. And you're concerned much more with trying to convey correctly the general features of what you're saying than the very specifics, the way we do when we're doing technical writing. And last and not least, treat media, your media encounters as fun. If you enjoy it, take the opportunity. So here's one story that was written about some work that we got when we did GPS studies in the New Madrid zone and found, to our considerable surprise, that you didn't see any strain accumulating, and strain accumulates before earthquakes generally. So this was a really interesting thing. It drew a lot of national attention, including the New York Times and so on. And we basically managed to make the story very clear. The motions are small to zero. It seems unlikely that strain is accumulating for large earthquakes. And this in turn was the beginning of a very large project that we had trying to understand earthquakes within plates. But the important is we were able to distill the message down to a very simple, clear way. So if you like to deal with the media, do so. Do it in a spirit of fun. Do it in a spirit of being helpful. Try to get your story out as well as you can. So good luck.